Hello and welcome to my channel. Vice Rhino here. Today, I'm headed back to Canada to look at our very own Ian Jubie. This is part of his Complete Creation series, which I started covering way back in 2020, though I did compile those videos into one of my signature Chungus cuts not too long ago. Anywho, his Complete Creation series is a really long one, so rather than take it sequentially, I just jumped into one that sounded interesting. Nuclear Physics for Home Educators, which is part 17. I assume that I'm just falling for his clickbait title and this will just be another creationist attack on radiometric dating, but hey, at least it sounds like something new, so let's give it a shot.
But let's move on to these actual ages assigned to the rock layers. Where did those ages come from anyway?
So, I know William Shatner's also Canadian. I promise we don't all talk like that. Anyway, it depends on the layer. The igneous layers can be directly dated using one of the many radiometric dating methods, so this actually kind of confirms my suspicion that the video won't be something new, as the title led me to believe, but will just be an attack on radiometric dating. Anyway, the igneous ones are radiometrically dated, and the sedimentary ones use relative dating methods, dating them based on the ages of their surrounding layers. There is more to it than that, of course, but I'm sure we'll get into it.
Surely those ages were arrived at by scientific process.
Indeed they were.
Actually, they were not.
What?
The long and short of it is that these ages were made up.
Nope. They were determined through a combination of measurement and calculation.
And then, as you'll see, the science was force fit to allegedly verify these ages.
Oh, I see what the problem is. You see, Ian, you are a creationist, which means that you have a predetermined conclusion that all data must point to no matter what. Creationist research journals will just come right out and say that they do that. Like the Answers research journal, which as part of its paper review process, it explicitly states that you must either formulate your paper within a young Earth, young universe framework, or if it discusses any evidence for an old Earth universe, it must criticize that evidence and provide a young Earth alternative. There's also a possibility of your paper being rejected if anything in the paper conflicts with the Answers in Genesis statement of faith. The journal Nature, by contrast, only requires that your research be original, of outstanding scientific importance, and reaches a conclusion of interest to an interdisciplinary readership. If creationist research didn't use flawed methodology to conclude what their research journals openly insist they must conclude, they wouldn't have any problem whatsoever publishing in Nature. But since creation science doesn't actually work if you don't start with the conclusion, they can't publish in reputable journals, and so resort to complaining about how the real journals just won't let them play, so they had to take their ball and go home.
So where did these ages come from in the first place? Well, it all started with the advent of index fossils.
Ah, yes. So he's clearly going for the they date the rocks with the fossils and they date the fossils with the rocks thing. But if you actually take a moment to understand what an index fossil is, that ceases to be a problem. Let's see how he does.
You recall that stratigraphic layers were found covering huge areas in multiple countries and continents. Those individual layers were identified by both their characteristics like rock type and their fossil content. The original geologists made an index of the fossils found in the individual layers so that the sedimentary layers could be identified and traced. Later on, with the advent of evolution, these index fossils were hijacked and used to construct this fictitious geologic column. Ages were then assigned to the hijacked index fossils.
He actually started out pretty strong there, but he lost it towards the end. The story of how we figured out the ages of the layers is a long one, going back to Steno's work in the 1600s. Steno proposed the ideas that came to be known as Steno's principles of stratigraphy. Simplified, that sedimentary layers are always deposited horizontally, that lower layers were deposited before higher layers, and that a layer will be continuous unless interrupted by a solid geologic feature like mountains. There's more, but that'll suffice for now. I'll go into more detail later if it becomes necessary. So, working with Steno's principles, Robert Hooke in the late 1600s and early 1700s noted that the fossil record could be used to construct a chronology, and while he didn't pin down exact numbers, he did mention that this chronology would antedate the pyramids, the oldest known human buildings at the time. Then in the 1700s, canal building really started to take off, which allowed people like James Hutton to study cross-sections of stratigraphic columns, which led him to the conclusion that the geologic cycle of rock deposition and erosion was an eternal one, stretching forever into the past and with no sign of ever stopping in the future. Lord Kelvin then showed up in the 1800s to put a limit on it by pointing out that the heat generated by the core of the Earth would not last forever, and likewise could not have existed eternally into the past. But there was pushback from geologists who saw Kelvin's calculations to result in an Earth that was far too young to account for what we see in the strata. A compromise was eventually reached by the end of the 1800s, with them settling on an age for the Earth of about 100 million years. But then Marie Curie came along and just messed everything up with the discovery of radioactive decay. Friggin' women, I swear, always messing things up with their scientific discoveries. Anyway, radioactive decay is a process that could have kept the Earth's core hot for far longer than previously thought. So, in the 1920s, as our understanding of radioactive decay improved, the consensus settled on 4.5 billion years for the age of the Earth, and that is where it has remained ever since. Now, certainly during the late 1800s, part of the reason that geologists were pushing for an older age than Kelvin was comfortable with was because of our new understanding of evolutionary processes. There needed to be enough time for evolution to take us from what we see in the fossil record to what is around today. But evolution was one small part of a very large puzzle. Also, I very much doubt that before the 1920s, scientists were assigning ages to the layers into the hundreds of millions of years just to accommodate evolution, when those same scientists believed that the Earth was only 100 million years old. So the idea that the ages came first and then the rest of the data was forced to fit the predetermined ages is just laughable.
Ultimately, all these ages come from evolutionary presumption. The ages are ultimately assigned to the fossils within the rocks, and the ages of the fossils are ultimately assigned by the presumption of evolution, and this presumed fossil sequence, which we've already seen, is actually fiction.
I'm assuming that him claiming the fossil sequences to be fiction is from a previous video in the series, so I'm not going to address that here. But no, we don't assume the ages of the fossils based on the presumption of evolution and their place within a fictional sequence. We date the fossils by figuring out the date of the rock that they come from. Yes, index fossils are a thing that can be used to get an initial date estimate, but they are not the only way to date other fossils, or the rock layers that they are found in. Just as a quick refresher, an index fossil is a fossil of an organism that is easily identifiable and has a known date range. If you find a trilobite, for instance, you know that the rock they were in will be somewhere between 521 and 252 million years old. Narrow down the species, of which there are over 22,000, and you've narrowed down the date range. Trilobites work as an index fossil because they are very easily identifiable, they have a very large geographic distribution, and they are abundant in the fossil record. This means that the likelihood that you found a trilobite that existed outside of their known range is minimal. They are so common that if they did exist in another time period, we probably would have found it by now. Of course, this doesn't mean that it is just assumed that you will never find one outside of its range. That's why they're not used exclusively as a dating method. They're more of a shortcut for dating estimates while doing field work and initial reporting. And notably, if an index fossil is found outside of its known range, the data is not massaged to make it fit back into the range that we decided for it. The known range just gets expanded.
All other methods or techniques of deriving the age of the rock bow to these assigned ages. For example, if you have a layer of rock like lavas, which do not contain fossils, the age of the lava flow is based upon the ages of the fossils below and above the lava flows.
For an initial estimate, yeah, that could be done. but igneous rock can be directly dated radiometrically. Actually, the only situation I'm aware of where sedimentary rock is used to date igneous rock is one where the sedimentary rock has already been dated using other methods, not just index fossils. If it hasn't, then it's more likely that the lava flow will be directly dated using several of the radiometric dating methods, and then the date for the sedimentary rock will be calculated based on the results for the igneous rock. Again, the presence of index fossils will help with this process, but they are not the linchpin.
So if you have fossiliferous layers below the lava flow that are assigned to, say, the Ordovician period, wait, why was that layer assigned to the Ordovician? Because of the fossils contained within the rocks and the presumed age of those fossils based on the evolutionary, geologic, and fossil column.
There we go. He took a while to get there, but we finally completed the cycle of they use the rocks to date the fossils and the fossils to date the rocks. He made it more complicated than it needs to be, but that's not really surprising coming from him. If you're unfamiliar, Ian's main claim to fame among creationists is that he is a member of Mensa, which means that his IQ was once measured to be at or above the 98th percentile. So despite the fact that he has come up with some of the most bizarre and obviously nonsense ideas in creationism, like when he said that a bunch of dinosaur eggs that were neatly in a row instead of in a circle were like that because the dinosaur laid them as it was running away from Noah's flood.
And again, apparently this dinosaur laid them in twos, but apparently laid the eggs on the run.
But despite him coming up with these crazy ideas that nobody should take seriously, he still brags about how smart he is. Well, I don't know if all the Mensa chapters use the same test, but I found a practice Mensa test and it was literally just a half hour of solving brain teaser puzzles, specifically Raven's matrices. The validity of IQ tests in general is questionable at best. Typically, IQ tests measure very narrow skills, and the translation of these skills into actual real-world intelligence is not apparent. And especially in a test that utilizes Raven's matrices, it's fairly easy to get a high score by just practicing a bit. At least, I'd assume so. The one I took gave me a result of 110, but I imagine I could do better if I tried again and didn't have kids interrupting me every few minutes. Maybe sometime between scripting and recording I'll find half an hour to waste doing the test without being distracted, but I honestly don't care enough about IQ to make the time for it. And as the person recording the video after the scripting happened, I can confirm that no, I didn't waste my time with it. Anyway, my point is that if there is one thing that could dispel the idea that IQ is a meaningful measurement of intelligence, it's that someone who's in the 98th percentile could think that dinosaurs running away from a flood while laying eggs would result in a perfect dual row of eggs.
There is no other reason for these assigned ages.
If that were true, your video wouldn't be called Nuclear Physics for Home Educators, now would it?
The ages were assigned to the fossils first, and then when the various dating methods were invented over the years, those dating methods were calibrated to those assigned ages. Now, as I previously showed, you can see how these ages changed over time. This was especially noticeable with the ages assigned to the dinosaurs.
Oh, come the fuck on, Ian. Do you not see the problem there? The ages were assigned, and then as dating methods were developed, they were calibrated to make sure they fit the assigned ages, but then the assigned ages changed? Why would the assigned ages change if they were making them up and inventing dating methods to confirm the already made up ages?
Now, one might contend that these ages changed over the years as the sciences improved and became more accurate.
And one who might contend that would be one who was correct.
But that is not at all what happened, nor is it even happening today. These ages became more or less set in stone, pun intended, around the 1940s to 50s.
I mean, it really depends on what organism you're talking about. There are new fossil finds fairly regularly, and each one has to be dated. And when a new organism is discovered, we go through the process of estimation and refining all over again, albeit quite a bit faster given the technological advancement that has been made since the 40s. But yeah, the major dinosaur age ranges are pretty well established at this point.
And as you're about to see, any scientific data that contradicts these ages is assumed to be incorrect and promptly tossed in the garbage.
The thing about science is that anomalies happen, contamination happens, mistakes happen, and so on. That's actually why peer review is so important. The reviewers can catch mistakes or problems of methodology that might have been overlooked by the original researchers. Along those lines, Yes, sometimes results are discarded when they are anomalous or show signs of contamination. So, how do we know that the accepted dates are not the results of contamination, anomalies, or mistakes? Well, for starters, they can be used to make predictions. Paleontologists don't just start digging in random locations hoping to find something good. They search for specific types of fossils in rock layers that should contain those fossils. A great example of this is the discovery of Tiktaalik. In a 1997 paper, before the discovery of Tiktaalik, it was predicted based on our knowledge of the fossil record and how organisms evolved, that an organism with the limb structure that would match what Tiktaalik has would have developed sometime during the Devonian. So a group of paleontologists set up shop on Ellesmere Island, where Devonian layers had been uplifted to the surface so they were easy to access, and after a few years of searching, they found Tiktaalik. That would not be possible if the ages were just made up to match evolution. They literally used evolution to predict where a specific type of fossil would be found, and they were successful. And this is not an isolated incident, it's just the most dramatic example that I can think of.
So if a method of dating a rock is invented, you have to calibrate that dating method using rocks of a known age.
Nah, man, that's a creationist misconception. The methods are not calibrated by testing them on rocks of known ages. They are calculations that are performed based on how we know certain elements behave in nature. Though, to be fair to most creationists, a sentence I never thought I'd say, they usually accept the basics of radiometric dating. You know, the whole radioactive elements decay at a constant rate thing? Creationists will usually get around it by either claiming that, well, the decay rates are constant today, they did change during the flood, or by bringing up the possibility of contamination in the rocks that are being dated. But the thing is, if you accept that radioactive elements decay at a constant rate, then you should recognize that you don't need samples of known ages to calibrate the dating method. It is simply a matter of looking at the ratio of daughter to parent isotopes in the sample and calculating the age of the rock from that ratio. I mean, I say simply here as though it's a calculation I could perform. It is not. I'll leave that to the professionals. But the underlying principle is simple. Though it is true that as new dating methods were being developed, they would compare them to already established dating methods as a kind of shortcut for determining accuracy. And as multiple methods came to be used, it became easier to pin down the accuracy of the various methods. Test a sample with multiple methods and see which ones agree with each other. Through applying this process, the methodology has been refined to a point where the dates are extremely accurate with a high degree of confidence. Creationists like to use this comparison with other dating methods to say that researchers will just throw out the dates they don't like, but they're just wrong.
That's just part of the process. So, they run the new dating method on rocks that they have declared are, say, 500 million years old. They might measure the ratio of the elements of uranium and lead, for example. They now take that ratio that they measured and compare it to other rocks of unknown age. If the numbers match the readings from the rocks 500 million years old, they then conclude that the age of the unknown rock is also 500 million years old. Notice there is no questioning of the age of the original rock used to calibrate the method.
Oh, I just love this. If you look at this slide that I prepared, you'll notice that I left out any mention of how they determined the age of the first rock. I can do that too. If you look at this slide that I've prepared, you'll see that the Ark encounter in Kentucky was completely destroyed by a flood. Of course, this isn't true. The property that was damaged in the flood was a bit of walking path, not the Ark itself, but the irony is still delicious there. My point is that anyone can make a slide that lies.
That age is presumed. So what is needed is a dating method which is independent of any calibration conducted using these literally made-up ages in order to test those made-up ages. Do we have any such dating methods? Oh yes, there's several.
Oh boy, I can't wait for this one.
Optionally, we can run tests using the various dating methods on rocks for which we can independently age. For example, if we can determine the age of a rock from archaeology or history.
How long do you think it'll be until he brings up Mount St. Helens, where a creationist geologist, it was either Snelling or Austin, they blend together in my mind, sent a contaminated sample in for dating and then cried victory when the contaminated bits resulted in measured ages greater than what he thought they should be based on when the eruption happened. Now, he's about to go into the basics of how radiometric dating works, which most of you are familiar with at this point, I'm sure, but if you're not, I'll direct you to my standalone video on dating methods and skip this segment. He does a decent enough job explaining it. Most of the quibbles I have are minor, which Makes me wonder at his earlier claim that the dating methods were forced to conform to the predetermined ages of the rocks they were used on. He gave a decently in-depth description of a half-life and explained how the ratio of daughter isotopes to parent isotopes is the basis of the calculation that resulted in that age. That's not something that you can just adjust to force fit into a predetermined answer, so why did he come to that conclusion? How did he come to that conclusion?
This is a wonderful theory, but it has so many fatal flaws that it's difficult to know where to begin.
Well, let's start at the very beginning. I hear it's a very good place to start.
Let's start with the assumptions. The first assumption that nobody ever talks about is very subtle yet significant. The assumption of billions of years.
Oh, wow. I was expecting either the constant of the decay rates or that there were no daughter isotopes present when the rock originally formed. I know creationists have to get back to the idea that the Earth and universe are about 6,000 years old eventually, but they don't usually start by saying, well, we know the universe is young, therefore anything that comes to the conclusion of billions of years must be wrong. I mean, they kind of do, they just don't usually say the quiet part out loud like that.
The bottom line is if that assumption that there has been billions of years is incorrect, then the rest of this dating technique gets thrown out the window.
Counterpoint, this dating technique is literally a part of how we discovered that the Earth and universe are billions of years old in the first place. Before radiometric dating came along, geologists were happy with 100 million year old Earth. Well, for the most part, that wasn't a universal position, but billions of years is the conclusion here, not an assumption.
But it gets better. There's also a major assumption of the starting point on this graph. Usually the amount of daughter element in the rock at its formation is assumed, and is usually assumed to be 0.
This is more like it. Yes, that one is an assumption in some cases. But, fun fact, there are radiometric dating methods for which this is not an assumption. In particular, any decay chain that ends at a daughter element that also has a stable isotope that is not the result of a decay chain. For example, radium-87 decays into strontium-87, which is stable. Strontium-86 is also stable, but is not the product of a decay chain. When forming, the rocks will not distinguish between strontium-86 and strontium-87, so they will be included in the rock at whatever ratio they were naturally present in the magma. If you take samples from several rocks that are formed in the same event, they may have different amounts of strontium-86 and 87, but the ratio between the two would have been identical at the time of formation. If you plot the samples on a graph, where the ratio of rubidium-87 to strontium-86 is on the x-axis and the ratio of strontium-87 to strontium-86 is on the y-axis, then at the time of formation it will be perfectly linear with a slope of 0. As time passes and radium decays into strontium-87, the relationship on the graph will remain linear, but the slope will increase. The steeper the slope, the older the sample. This dating method, rather than assuming 0 daughter isotopes were present, actually accounts for the presence of daughter isotopes. So even if I grant that this is a problem for the other radiometric dating methods, we know that the Earth is billions of years old from methods that do not have that problem.
There is 0 reason for that assumption. In fact, you advocates of deep time, answer me this question. How were the elements of the universe formed?
The Big Bang formed several variants of hydrogen and helium, as well as some lithium and beryllium, and possibly tiny amounts, relatively speaking, of boron. The distribution of these elements was uneven, which caused some areas to gravitationally collapse and eventually forming stars, which fused these elements together into heavier elements up to iron. A lot of the elements heavier than iron are also formed in stars through what is called the slow neutron capture process, which is fed by neutrons released by carbon atoms produced by the stars. Shockwaves caused by stars going supernova can also produce elements between iron and rubidium. Heavier elements are also formed by neutron star collision, which includes gold and the heavy metals. And there are a handful of other processes like spontaneous fission and cosmic ray spallation as well.
The heavy elements in particular.
Neutron star collision, the slow neutron capture process, and black hole accretion disks.
Now, I already know the answer is we don't know.
Oh, whoops. My bad. Ignore everything I just said and replace it with, I don't know. Apparently that's the real answer, despite most of what I said being explained in the scientific literature in the 1950s, with the building blocks leading to those discoveries showing up in the 1920s.
And that the only naturalistic theories are wild speculations that defy all scientific observations.
If by that you mean calculations based on an extrapolation of the laws of physics into the past, then Sure, but yeah, no, there's actually no saving that one. You're just wrong.
But nevertheless, I'm going to be gracious and give you whatever theory just shot through your mind. Let's assume your theory is correct.
It's a theory that has, over the years, made several testable predictions. I'm talking, of course, of the theory of relativity. That's where all these calculations ultimately come from. And the theory of relativity in 1915 predicted the existence of gravitational waves, which were first observed by LIGO a century later in September of 2015. It's weird how you keep accusing researchers of just making shit up, when the shit that they supposedly made up can be used to accurately predict aspects of reality. And in relativity's case, you literally use it in your day-to-day life. And I'm not just talking about the GPS satellites, which have to account for time dilation when calculating your position, but anything that uses an electromagnet relies on special relativity. The whole reason why a wire carrying an electric current creates a magnetic field is because of relativity. To simplify a very complicated explanation, the faster something is moving, the more compressed it will appear along its axis of motion to a stationary observer. If this were not the case, then an electric current traveling through a wire would not produce a magnetic field, as the overall charge of the wire would remain neutral. But electrons move just fast enough that, from their frame of reference, it's the protons that are moving, which causes them to be contracted, resulting in a positive charge that we outside the wire see as a magnetic field. Relativity works, and relativity is where we got the Big Bang from, so you've got a lot of observational science that needs to be explained before we can discard the Big Bang and all its downstream implications.
I'll just pull one argument out of a hat. Nuclear fusion in deep in a star produced heavy elements like uranium-238.
And that shows that you either don't actually know what the real answer to your question is, or you're lying, because it is well known that stars do not produce elements heavier than iron through fusion. Uranium would have been produced using one of the many other methods that I mentioned earlier, not stellar fusion.
Will that process that produces uranium-238 also not produce lead-206?
Perhaps, but lead is definitely produced by dying low-mass stars in one of the methods of elemental production that I hadn't mentioned earlier. So regardless, yes, we get lead through non-radiogenic means, which isn't an issue. Nobody is arguing that lead didn't exist at all on the early Earth. Even if we only got it from decaying uranium, the universe is old enough that there likely would have been some cosmic lead floating around when our solar system formed.
You have no valid starting assumptions. None. You have no idea what the original mixture of elements in the rock sample was.
I would once again like to direct your attention to the existence of isochron dating. There are also several trapped charge dating methods, which don't rely on assuming the composition of a rock at its formation. Essentially, they rely on measuring how much radiation a sample was exposed to while it was buried, measuring the background radiation at the site where it was discovered, and calculating how long it would have taken to reach the measured level of exposure. These methods are typically only reliable on samples younger than 1 million years old, but that's still a couple orders of magnitude longer than Ian thinks the universe has been around. I mean, technically, I guess there is no upper limit on how old a sample could be and still be dated with electron spin resonance in particular, but past 1 million years it gets increasingly unlikely that the requirements a sample needs to meet in order to be datable with this method will be met. But even though isochron and trapped charge dating don't rely on our knowledge of the original contents of the materials they are dating, and either one gets us to ages that are well older than Ian would accept, it actually turns out that this isn't even a huge problem. You see, uranium series dating is not, strictly speaking, dating when the rock itself was formed. It's dating the element fractionation process. Fractionation is when a mixture of something, in this case isotopes, are divided during a phase transition, in this case the cooling of magma into solid rock. Because of the different properties of the various isotopes involved in the uranium series dating, they will behave differently during the cooling process and will be incorporated into the crystal lattice of the forming rock at different ratios. In addition to this, thorium is an important part of uranium series dating, as thorium-232, which has a half-life that is longer than the Earth is old, can be used in a process that's very similar to isochron dating to determine the original ratio of uranium-238 to thorium-230 in a sample. Uranium series dating also has this neat little quirk where any system after 5 half-lives of uranium-234 have passed will be in what is called secular equilibrium. That is, All of the elements in the series will now decay at the same rate, and their isotope ratios are the same as the ratios of their decay constants, a feature that allows the initial ratios at the time of fractionation to be calculated. Now, when we come back in, I will have skipped past a couple things. The first is that he talks about radon gas and how it is part of the uranium series decay chain, and being a gas, it can escape and mess with the dates. Of course, this would also mess with the system's secular equilibrium, so it can be accounted for. And then he gives an overview of the potassium-argon dating method, which is good enough, but takes too long. To summarize, argon-40, being an inert gas, will escape from magma before it cools, potassium-40 will be absorbed into the lattice of the rock, so any argon-40 that's found in the solid rock will be the product of radioactive decay of potassium.
So we assume that the graph really does start with argon at 0 when the rock cools and solidifies.
Despite what I said earlier, no, we don't. Not all of the argon will necessarily degas during the cooling process. What he didn't mention in his explanation is that there are multiple isotopes of argon. Argon-36, for instance, can be used to determine the amount of argon-40 that would have remained in the rock as it cooled. Again, this is similar to what they do with isochron dating, but not quite the same. The cooling magma would not differentiate between argon-36 and argon-40, so with some math that the research papers assure me is quite simple, excess argon can be accounted for while using potassium-argon dating. I'm skipping ahead again as he just finishes with the explanation of how the ratio of potassium to argon is the basis for dating the rock.
On May 18th, 1980, Mount St. Helens in Washington state erupted.
If, earlier, when I asked how long you think it would be before he brought up Mount St. Helens, you guessed 14 minutes and 38 seconds, give yourself a pat on the back, you were correct. Of course, that's how long passed in his video. I imagine it would be significantly longer between the two in mine, although I did skip about 10 minutes of his video in the middle there, so maybe not. But hey, it's me. I do not doubt for a moment that I inserted more than I took out. That's what she said.
Inside the new crater, a lava dome grew over the next couple of years. We now know the actual age of that lava dome because we watched it grow.
I suspect this will be important in a moment, but keep in mind that there were several eruptions all throughout the 80s. It wasn't just the one single eruption from 1980.
10 years later, Dr. Steve Austin from Institute for Creation Research, now headquartered in Dallas, Texas, collected samples of that lava dome and processed the rocks through the potassium-argon dating method.
Incorrect. 16 years after the 1980 eruption, Steve Austin collected samples from a portion of the dome that formed in 1986 and sent them in for dating. I am being a touch nitpicky here, but I feel like getting the details correct is important. A feeling that Austin and Juby don't seem to share. Because before we even get into what Austin's findings were, it's important to point out that the lab that he sent his samples to for dating, Geochron Laboratories, had a warning prominently displayed on their website that they are incapable of analyzing samples that are expected to be younger than 2 million years. And in this same paper, Austin copied data from the wrong column of a table in a paper that he was referencing. He copied out a table showing the measured ages of various rock samples from events that occurred at known dates, with the intention of calling into question the certainty of argon dating. Of course, while he did mention that the argon measured in that paper was excess argon, he didn't go into detail about the fact that the paper was entirely about the methods that can be used to detect and correct for excess argon. So, yeah, maybe I am on the nitpicky side here, but someone has to get the details right.
5 samples from the same lava dome, the same rock, returned ages of 350,000 to 2.8 million years old.
Now, we already know enough about Austin's paper to dismiss these results entirely. He sent 10-year-old rock samples to a lab that was incapable of dating anything under 2 million years, so obviously the results are going to be meaningless. But it gets worse. In Austin's paper, he acknowledges that his samples are impure, with all of them containing some glass. There are 2 major issues here. The first is that when explaining why the impurities in a sample aren't a problem, he appeals to an earlier paper that determined that the inclusions in their samples were not xenoliths, which are older rocks that got trapped within the lava as it cooled without melting themselves, which would throw off any measured dates if you weren't careful to avoid them in your sample. But their xenoliths were associated with the magmatic system itself. Why is this a problem? Because the paper he used to support the idea that the impurities in his samples could be safely ignored only looked at the lava dome that formed between 1980 and 1983. The samples that Austin took didn't even exist when this paper's samples formed. You can't just assume that every eruption is going to have identical characteristics. The second, and even worse major problem, is that even if I grant that the paper looking at the 1980 to 1983 material could be reasonably applied to the 1986 material, they also determined that their samples contained up to 9% interstitial glass. This is an even bigger problem than the first one, because a 2011 paper found that glass contamination significantly messes with the potassium-argon dating method, making samples that contain as little as 0.01% glass by weight return ages significantly older than they actually are. And this effect is one that diminishes over time. It would be at its worst in a young sample. And when they say young, they're talking hundreds of thousands of years. Austin's 10-year-old rock samples with potentially 9% glass contamination wouldn't stand a chance.
So now that you guys are experts in potassium-argon dating,
I know he's trying to be a bit facetious with that wording, but no, actually, scrap that. I don't know that he's being facetious. This is his lead-in to explaining why a geochemist, an actual expert, is wrong about potassium-argon dating. So yeah, remove everything that I added to his explanations of how radiometric dating works, and you basically get one isotope decays into another over time. The time it takes to do that is a constant that is known. So measure the ratio of the daughter isotopes to the parent isotopes, and you can calculate the age. If that is all creationists think you need to know to be an expert, then no wonder they also think they can disprove several entire fields of science by just yelling thermodynamics at them or something similar.
You can analyze for yourself the response of Dr. Kevin Henke from the No Answers in Genesis website. In attempting to refute Austin's research, he actually made numerous very revealing statements. See if you can spot the error of his ways. Considering that the half-life of potassium-40 is fairly long, 1,250 million years, the potassium-argon method cannot be used to date samples that are much younger than 6,000 years old. A few thousand years are not enough time for argon-40 to accumulate in a sample at high enough concentrations to be detected and quantified.
I don't see any issues there. He also goes on to explain what I've explained here about how the lab he sent his samples into wasn't equipped to date young samples, and points out several issues with Austin's methodology, including the failure to avoid glass contamination in his samples, the fact that he admits that iron mortar likely contaminated his sample, his failure to account for phenocrysts and xenocrysts, and more. So sure, read the first couple sentences of a 45,000 word article so that you can pretend like you're actually countering the critics, but there's some stuff in the rest of those 45,000 words that you should probably be aware of before pretending to have expertise on the matter.
Wait, did he just admit that if the rocks being dated were only 6,000 years old, that the radio dating methods would give an erroneous, inflated age of millions of years?
Okay, I see where you're going. Yes, he did say that. But if you carry on reading his article, you might learn that the reason for the samples appearing old when they are young would mainly be due to the contamination in the machinery used to do the measuring. That would not produce reliable results that agree across multiple dating methods, which is a thing that happens all the time. And that's it for this one. Today's comment of the day comes to us from Terrence Clark, who says, "The thing that really gets me about the comments criticizing you and really most other atheist response channels aiming for the low-hanging fruit is the arguments are almost always the same between the low-hanging fruit and the big-name apologists. They're not different. About the only major difference is the big-name apologists have more practice at it and are better at the rhetoric." Yeah, that was something that I noticed fairly early on. Frank Turek was actually the guy who clued me into this. I avoided covering Frank for a couple of years when I started my channel because I had heard about how good he was, and countering that seemed like it would be a lot of work. And that's why Frank will always have a special place in my heart, because he was the one who led me to discover that all apologetics are kind of shit. It's just that the low-hanging fruit ones don't know to spritz the shit with perfume to make it less obviously shit. Thanks for watching. I'll be back next Friday with more, but if you need to get your Rhino fix in before then, I live stream with Cirrus every Wednesday, 8:30 Eastern on my other channel, The Watering Hole. Thanks to Tim Robertson for being my Patreon and sponsorships manager, Piper for being my editor, and special thanks as always to my patrons, who are the glass that contaminates the sample that is my channel. If you'd like to be full of argon, you can join us on Patreon for as little as $1 per week over at patreon.com/ViceRhino, or by supporting the channel in one of the other methods that can be found at links.vicerhino.com, which is also where you'll find links to my other projects. If you've got fan art that you'd like to be featured behind me, post it on Blue Sky and tag me. I'm at vicerhino.bluesky.social, or I guess it's bsky.social. If for whatever reason you want to send me stuff, my PO box address is in the description. See you next time! I'm recording on Valentine's Day instead of doing sexy things with my partner. It's okay though, because she's at work. I got the clap and I'm giving it to you. I got the clap and I'm giving it to you.